I am T.Kavitha, Assistant Professor, Department of Mathematics. Today we are going to see the topic of case study on limit of a function. First, we give the introduction of limit of function. The limits of function is, in calculus, the limit of function is a fundamental concept that describes the behavior of a function as the input values get arbitrarily close to certain point. The limit of a function f of x as x approaches a specific value, denoted as limit x tends to a f of x, represents the value of f of x approaches as x gets arbitrarily close to a. Mathematically, the limit is defined as follows. Limit f of x tends to a is equal to L. This means that as x gets arbitrarily close to a, the values of f of x gets arbitrarily close to L. Example number 1. We explain the limits as a example problems. Consider the function f of x is equal to 2x plus 3 and find limit x tends to 4 f of x. We directly substitute x is equal to 4. Then limit z tends to 4 2x plus 3. We substitute x as 4. As x approaches 4, the expression 2x plus 3 approaches 2 into 4 plus 3 is equal to 11. Therefore, the limit x tends to 4, 2x plus 3 is equal to 11. Example number 2. Find limit z tends to 1, x square minus 1 by x minus 1. Here we substitute directly z as 1, then we get z square minus 1 by z minus 1. We substitute z is equal to 1, then 1 minus 1 by 1 minus 1, we get 0 by 0 form. Then we cannot find the limit value. So we factorize the value of z square minus 1, then we get the simplify of the expression. Limit z turns to 1, z minus 1 into z plus 1 divided by z minus 1. The factorization of z square minus 1 is equal to z minus 1 into z plus 1. Now the z minus 1 term is cancelled. Then we substitute z is equal to 1. As z approaches 1, then the expression approaches 1 plus 1 is equal to 2. Therefore, we get the limit as 2. Next problem, evaluate limit x tends to infinity 3x square minus 2x plus 1 by 2x square plus 5. Here the limit is indefinite limit, infinity. Therefore, limit x tends to infinity 3x square minus 2x plus 1 by 2x square plus 5. We use the another method. Divide both the numerator and denominator by the highest power of x. Then the highest power of x is here, x square. Then we divide all the numerator and denominator values divided by x square. We get limit x tends to infinity 3x square by x square, we get 3, minus 2x by x square, we get minus 2 by x, plus 1 by x square divided by 2x square by x square, we get 2 plus 5 by x square. Here now x approaches infinity. The terms 1 by x and 1 by x square become negligible. That is 1 by x and 1 by x square value is 0. Then we substitute the values. 3 minus 2 into 1 by x is 0. Therefore, the total value is 3 by 2. Then therefore, the value of the limit in this problem is 3 by 2. Next one, case study problem. That is, imagine a scenario where you are tracking the growth of population of bacteria in a lab. The population at a time t is modeled by the function p of t is equal to 1000 into e power 0.05 t, where p of t represents the population in thousands and t is measured in hours. Your goal is to determine the population of bacteria is at a specific moment in time, say t equal to 10 hours, and also investigate the behavior of the population as time approaches infinity. Therefore, we have to find the two situations and in the answer. Number one, population at a specific time. Find the population of bacteria at t equal to 10 hours. P of 10 is equal to 1000 into e power minus 0.05 into 10. Using calculator, we get P of 10 is approximately 1000 is equal to 1000 into e power 0.5. Then e power 0.5 value is 1.648721. Then P of 10 is equal to 1648.721. Next, the behavior as t approaches infinity. T approaches infinity, we get limit p of t tends to infinity. Then limit t tends to infinity 1000 into e power 0.05 t. At t goes to infinity, the exponential terms dominates, then and e power 0.05 t becomes very large. Therefore, the value of limit t tends to p of t is going to infinity. This indicates the population bacteria grows without bound as time goes to infinity. Thank you.